Now, the arbitrary CPI vulnerability. On Solana, programs often rely on CPI to use logic to move tokens and to interact with other protocols. This is normal, this is how Solana works. But the problem starts when a program doesn't verify and doesn't strictly control which program it is calling. If a user is allowed to pass in a program ID and your program blindly uses it for CPI, then you're no longer calling a trusted program. You're just calling a program the user wants. From the outside, everything might look fine, the CPI succeeds, the transaction doesn't fail, but deep down, your program has just executed on short transactions without making sure the program being sent to is actually real or not fake. That's where the arbitrary CPI vulnerability stems from. Now we have this scenario, a tip jar, a simple tipping DApp that sends SO to content creators. The architecture is that these tips are sent via CPI to the system program for transfers, which is normal Solana pattern. But the bug is that the system program account is accepted as a raw account info without validation. So the story has it that the developer deployed tip jar and noticed that tips weren't arriving. So he was sending transactions, but the tips were showing being sent successfully, like when you send the transaction and you see transaction sent, but the receivers never received any. So the issue came from this. When you pass in system program as account info, your program is unable to validate to actually confirm if it's the real system program or maybe a fake one, a clone with vulnerable intentions. You see this here. So if your system cannot confirm that we have the SO 111, means that your system cannot be trusted. Instead of using the account info type, we're better off with the program type, where we can pass in the system type, which actually validates to ensure that what is being passed in is the system program. If someone tries to pass in a fake program ID, you get this error with account validation. But with this interface or with this style, you don't get any error. Your system just takes in anything, garbage in, garbage out. So we'll move over to the exploit section to see how this applies in real time. Now in the simulation arena, we have arbitrary CPI, and we have the tipjar example as shown in the first part here. So tipjar accepts so via CPI to system program. Now let's test out the vulnerable version. This tipjar, let's assume we want to send 0.01 so to someone. We intend to use the fake program ID. Here now, behind the scenes, we're passing in the token program instead of the system program. Watch what happens. We'll send it, sign the transaction, and passing fake. You see that the transaction passes, no error, but this is a log here. You see that you passed fake program ID and the transaction passed, but the balance never got updated. You see it, like I explained in the initial story. But if we go the secure route, let's take this. You get an error that is a fake program ID is passed. So behind the scenes, you get this error, which is this. But this is just a front end throwing error from the terminal. You get the system blocks it immediately, showing that the fake program ID cannot be allowed. So if we try to send with the regular program ID, you see the money gets deducted and you see the tip being added to the user's account. So this is how the arbitrary CPI works. I mean, you can be making transfers, assuming that it's getting to the user. Meanwhile, it's not getting there because you're using this account info instead of validating with the system program.